Aside from sine and cosine function, we also have a couple more of a trigonometric function, that is tangent, cosecant, secant, and cotangent. Let t be any real number, and let p, the point x, y, be the terminal point on a unit circle determined by t. We define sine of t equal y, cosine of t equal x, tangent of t equal y over x, or we can look at this as sine over cosine, sine of t over cosine of t. Note that we define that where x is not 0, which means cosine of t is not 0. Cosecant of t is 1 over sine, secant of t equal 1 over x, cotangent of t equal x over y. Note that all the three trigonometric functions, they are the reciprocal of sine of t, cosine of t, and tangent of t. Let's take a look at some fundamental identity. The Pythagorean identity, sine squared of t plus cosine squared of t equal 1. We've seen that up in the previous section. We also have 1 plus tangent squared of t equals secant squared of t. 1 plus cotangent squared of t equals cosecant squared of t. Now you only have to remember this first one here. This 2, you can derive it from the first one. So for example, start with sine squared of t plus cosine squared of t equal 1. If we go ahead and divide the equation entirely by sine squared of t, again, when you divide by something, make sure you divide to everything. Now then we get 1 plus 1 plus cotangent squared of theta equal cosecant squared of theta. So here we derive this equation. Now if we want this equation right here, we can go ahead and divide the sine squared of t plus cosine squared of t equal 1. We go ahead and divide it by cosine squared of theta. You will get 1 plus tangent squared theta equal to secant squared theta. We also have the reciprocal identity. Tangent of t equals sine of t divided by cosine of t. Secant of t equal 1 divided by cosine of t. Cosecant of t equal 1 divided by sine t. Cotangent of t equal to 1 divided by tangent of t, and that is the same as cosine of t divided by sine of t. Quadrant angle. Quadrant angle are angles that lie on the border between the quadrant. In other words, on an x or y axis, when this happens, either x equal to 0 or y equal to 0 would result in some of the trigonometric function being undefined. So for example, tangent of 90 degrees is undefined. So let's double check this. So remember, tangent of 90 degree, that is equal to sine of 90 degree divided by cosine of 90 degree. So 90 degree is this angle. On a unit circle, we have this coordinate being 0, 1, which means that sine of 90 degree equal to 0, cosine of 90 equals 0, and sine of 90 equal 1. So tangent of 90 degree equal undefined here in this case. Now, the xy axis divide xy plane in 4 quadrants would then result in quadrant 1, all 6 trigonometric functions are positive. This is because in quadrant 1, the both value x and y are positive, which means cosine and sine are positive, right? In quadrant 2, only sine is positive and cosecant are positive. The rest is negative. Why is that? Because here x is negative and y is positive. Since sine is y and cosecant is 1 over y, that is the only value that is positive. The rest of the trigonometric function involved in some form of x, so then that y it is negative. In quadrant 3, well, only tangent and cotangent are positive because tangent of theta is equal to y divided by x. So when you have negative divided by negative, it's become positive, right? And in quadrant 4, only cosine and secant theta are positive. Again, same argument because x is positive and y is negative in this quadrant. Let's take a look at an example. The point xy is on the unit circle. Find the value of the trigonometric function associated with p. So in the first point, p equals square root 2 over 2, square root 2 over 2. We have x equal to square root 2 over 2. And y equals square root 2 over 2. The point pxy is on the unit circle. So then sine of t is equal to square root 2 over 2. Cosine of t equals square root 2 over 2. Tangent of t is equal to root 2 over 2. Divide by root 2 over 2. That is 1. Cosecant of t, that is 1 over sine, so that is 2 over root 2. That makes root 2. Secant of t, that is 1 over cosine, so 2 over root 2. Again, that is root 2. Cotangent of t, that is 1 over tangent. Tangent is 1, so this is 1. In the next one, we have x equal to negative root 3 over 2. Y equal 1/2. So sine of t equal 1/2. Cosine of t equal negative root 3 over 2. Tangent of t is equal 1/2 divided by negative root 3 over 2. That is 1 over negative root 3. Rationalize the denominator, so we get negative root 3 over 3. Cosecant of t, that is 1 over sine of t. So that is 1 over 1/2. That makes 2. Secant of t equal 1 over cosine of t. That is 1 divided by negative root 3 over 2. So then we get negative 2 over root 3. Rationalize the denominator, we get negative 2 root 3 over 3. Cotangent of theta of t equal 1 over tangent of t. So that is 1 divided by negative root 3 over 3. That is negative 3 divided by root 3, and that makes negative root 3. Similarly, you can find the value of the sixth trigonometric function for part C on your own. I'll talk a little bit about part D. Sine of t here in this case equal negative 1. Cosine of t equal to 0. Tangent of t equal to sine divided by cosine, negative 1 divided by 0. This is undefined. Cosecant of t equal negative 1. Secant of t 1 divided by 0 equal undefined. cotangent of t equals 0 divided by -1. That is 0. So note that there's something to see here. The reciprocal of 0, that is undefined. The reciprocal of undefined is 0. Now, we've seen that if we are given a point on the terminal point on the unit circle, we can calculate the value of the trigonometric function. So let's say, what if we are given the value t and we go ahead and we need to find the value of the trigonometric function associated with t. First, you need to memorize your unit circle and think about what is the terminal point that you should be having. So let's take a look at the first one. T equal to pi over 6. When t equal to pi over 6, according to your unit circle, the terminal point here is p square root 3 over 2, 1/2. So then we can find the value of sine and cosine and the other trigonometric function here in this case. So sine of pi over 6 is equal to 1/2. Cosine of pi over 6 is equal to root 3 over 2. Tangent of pi over 6 is equal to 1/2 divided by root 3 over 2. That is 1 over root 3, and that is root 3 over 3. Cosecant of pi over 6 equal to secant of pi over 6 equal to 2 over root 3, and this is 2 root 3 over 3, rationalize the denominator, and cotangent of pi over 6 then equal to square root of 3. For t equal to negative pi over 3, you remember your unit circle, we don't have a negative pi over 3 on our unit circle. However, we can find what is the value of, we can find what quadrant that negative pi over 3 is on, and we can find the same value that would end up on the unit circle. So we want something that in between 0 and 2 pi. So I go ahead and add 2 pi into negative pi over 3 to figure out what quadrant that is t belong to. So I go ahead and add pi over 2. That's 2 pi, I mean. So this equal to 5 pi over 3. Okay, so if you look at your unit circle, you'll see that we have a terminal point for 5 pi over 3 that is p of 1/2 negative root 3 over 2. Now we can use though to find the value of trigonometric function. Okay, I'll leave that to you. It is similar with what you have in part A. Again, in part C, we don't know what is this value of 27 pi over 6. So we have to find the coterminal that is on the unit circle. I'll do that by continuously subtracting 2 pi to 27 pi over 6. Well, 15 pi over 6 is not quite the value that I want. It's not between 0 and 2 pi. So I'll do that one more time. And simplify this to get pi over 2. So on our unit circle, pi over 2, the terminal point for pi over 2 is 0, 1. So then sine of t or sine of 27 pi over 6 is equal to 1. Cosine of 27 pi over 6 is equal to 0. Tangent of 27 pi over 6 equal undefined. Cotangent of 27 pi over 6 equals 0. Secant of 27 pi over 6 equal undefined. And cosecant of 27 pi over 6 equal 1. Let's say we're given t equal to negative 13 pi over 2. Again, I want to find the coterminal angle of negative 13 pi over 2 so that I get something on the unit circle. So I go ahead and add 2 pi here. And that gives me negative 13 pi over 2 plus 4 pi over 2. That is negative 8 pi over 2. So negative 8 pi over 2, that will be negative 9 pi over 2. Again, I will add 2 pi. That gets me negative 5 pi over 2. So one more time, negative 5 pi over 2 plus 2 pi. That is negative pi over 2. And negative pi over 2 plus 2 pi. That is 3 pi over 2. So 3 pi over 2 on the unit circle is right here. Just have the terminal point of 0, negative 1. Now that we have the terminal point 0, negative 1, you can go ahead and calculate the value of opposite trigonometric function on your own. So do we always given some angle that is on the unit circle or some special angle to calculate the value of sine and cosine? Well, in reality, that's not always the case. Not true. So how would we calculate the value of sine and cosine if they are not on the unit circle? Well, that's what the calculator are for. So let's take a look at this example on how to use the calculator. We want to evaluate the following trigonometric function, and we want to round the answer to the nearest 10,000. So nearest 10,000 is how many zero? So nearest 10,000 would mean 4 decimal places. Let's see how we would use calculator to calculate in this. So here I have a TI-84. We want to calculate sine. So on this calculator, we have the value of sine, cotangent, sine, cosine, and tangent. So sine of 4, that equal to negative 0.7568 and 4 decimal place. So that's what we rounded to. So sine of 4 equal to negative 0.7568. How about sine of negative 2.8? Again, sine of negative 2.8, that is negative 334. So here we need to round it up, so that is negative 3350. Tangent of 4.5. That is 4.6373. Cotangent of 6.7. Well, if you look at the calculator, we have the button for sine, cosine, and tangent, but we don't have the button for cotangent. Now, remember this, with a fundamental identity that said cotangent is 1 over tangent. So I can find this value, 1 over tangent of 6.7. Okay, so we have to be very careful putting this into your calculator and make sure you have all the parentheses appropriately. So 1 divide tangent of 6.7. We'll close that. And that is 2.2586. Now, similarly, if you need to calculate the value of secant and cosecant, you need to use the reciprocal of sine and cosine, respectively. So let's take a look at the domain of trigonometric function. Sine of t, cosine of t. Remember, t is the terminal point t is a value on the unit circle. Okay. And it can go around a unit circle as many times as 1, right? So this t value can be all real number. So it's from negative infinity to infinity. For tangent of t and secant of t, so recall tangent of t, that is equal to sine of t divided by cosine of t. Well, this function is undefined when cosine of t equal to 0. You look on your unit circle, cosine of t equal to 0 at pi over 2 and 3 pi over 2. So t cannot be equal to pi over 2 and 3 pi over 2. So from pi over 2 to 3 pi over 2, the difference is at pi. So for every pi period, tangent of t is undefined. So then the domain for the function of tangent of t and secant of t is all real number except that is not 2n plus 1 pi over 2, and n is of any integer. Cosecant of tangent theta, well, recall that cotangent theta is equal to cosine of t divided by sine of t. Well, sine of t cannot be equal to 0. Well, sine of t equal to 0 when t equal to 0 and pi. Okay, and I keep going, 2 pi, 3 pi, 4 pi, so on and so forth. So the difference of this is pi. Okay. Now, so the domain here is all real number. That is not n pi, for n is integer. Now the reason that in this, for tangent and secant of theta, I started 2n plus 1 is because the first number here, this is 1. So this is odd, right? The next one is 3, that also odd. The next one that would make this undefined is 5 pi over 2, 7 pi over 2. So you note that all this value are odd number. So to represent an odd number, that is 2n plus 1, where n is integer.